Today we're going to talk about the different type of numbers. First, we have natural numbers, sometimes called the counting numbers, and they're basically what they say. Where do you start counting from? 1, 2, 3, etc. If you add a 0 to that, you get whole numbers. So whole numbers are 0, 1, 2, 3, etc. Integers are whole numbers and their opposites. So 0, 1, 2, 3, etc., but also -1, -2, -3. Rational numbers we've already talked about, any number in the form a over b. So remember, that includes repeating decimals. So repeating decimals are rational numbers. So a repeating decimal you can write as a fraction. Then the new one we're going to talk about today, irrational numbers, are numbers that can't be written as a terminating or repeating decimal. They go on forever without a pattern. Two examples are pi, probably the one you know the most, and then the square root of 2 would also be an example of an irrational number. So part of our work today is just classifying numbers as to what they belong to. Now they can belong to more than one set. So 5/22, is it a natural number? No, you don't say it when you count. Is it a whole number? No. Integer? No. Is it rational? Yes. So you can put down rational because it is written in fraction form. And then if it's rational, it will not be irrational. To do number 2, the square root of 121, you need to simplify it first. Well, I hope we know that that is 11. So is 11 a natural number? Yes. Is it a whole number? Yes. Is it an integer? Yes. And is it a rational number? Yes, it can be written as a fraction if you write 11 over 1. So it would be all of those. So when you're doing your work today, make sure you put down all possible things that it could be. In number 3, you need to simplify the square root of 56, so you can use your calculator to do that. And if you do that, you are going to get 7.4833147774, and it goes on forever, so this would be an example of an irrational number. -36 divided by 4, if you simplify that, you're going to get -9. So that's not a natural or a whole number, but it is an integer, and it is written as a fraction, so it is a rational. So it would be those two types of numbers. These we're going to graph on a number line, so it's not just whole numbers now, it's all numbers included that are going to be less than -2. So if we put 0, 1, 2, 1, 2, 3 over here, is -2 greater than -2? No. So it's -2 is not included, so it's an open circle. Which way are numbers greater than -2? These numbers out here. So we draw the line and we put the arrow on it. So those would represent all numbers greater than -2. To do number 6, it's numbers less than or equal to 4. Again, you need to be able to read those signs. So make our number line. Remember to put your arrows on the end of your number line. Is 4 less than or equal to 4? Yes, it is. It's included, so you color in a dot above there. And where are numbers less than? 3, 2, 1, this direction with the arrow. So make sure you color in the dot if it's included. Open circle if the number is not part of the solution. Now we're going to use our calculators to do some of this. We want to put in a less than, greater than sign, so we need to get them in the same form. So I'm going to use my calculator to find the square root of 19, and it is 4.358, etc. 4.358. So comparing the same places, 4 is greater than 3, so it would be a greater than sign. So to do this one, I want to find the square root of 52, which is 7.211. And remember, this is 7.2 repeating, so the 7's are the same, the 2's are the same. The next number I'd be comparing would be 2 with a 1, so 2 is greater than 1, so it would be a greater than sign in there. So get them in the same form, and then you can compare them by comparing the places. This one we want to put in order from least to greatest, so we need to change them all into decimals. So if I take the square root of 7, that is 2.645, so -2.645. To change 8/3 into a decimal, I'm going to divide 8 by 3. Again, you're using the calculator. This, I get 2.6 repeating. So this is 2.6 repeating. Change 53/20, I take 53 divided by 20, and it would be -2.65. And I want to find my least, and when I say show work, that would be showing what you've changed them into. And remember, when you do write these numbers, go back to the original numbers. So the smallest have to be my negatives. I'm going to look at my two negative numbers, which are these right here. negative 2.64, negative 2.65, and remember we're thinking smallest now, so really this one would be the farthest to the left on a number line, so I'm going to write it as negative 53/20ths. So go back to the original number when you do write these. So then would be my other negative number, negative the square root of 7. So now I'm ready to look at my two positive numbers. This is 2.63 and it repeats, so 2.63, 63, 63, and this is 2.6 repeating, so it would be a 6. So 3 is less than 6, so this would be my next number, 2.63 repeating, and then the final number would be then the 8/3, and that would put them in order. But make sure you show this work and go back to the original numbers when you write things in there. What type of number would you get if you do the following? If you add a rational number and a rational number, what type of number would you get? Well, if you add a number that ends to another number that ends, it would be a number that ends. So it would be a rational number. So think about whether it ends or keeps on going. If you add a rational to a number that goes on forever, it would have to be a rational number because it's going to go on forever. If you add two irrationals, they again would go on forever, wouldn't they? So it would be an irrational number.